already studied that the strength of the solution is the concentration or quantity of the solute in the given volume of the solvent. But here the meaning of strength of acid is different from that. In that sense, when acid dissolves in the water, it gives hydrogen ion either easily or with difficulty. On this basis, we decide the strength of acid. And that acid which gives hydrogen ion easily or in greater quantity, that acid will be a stronger acid, and that acid which gives less amount of hydrogen ion in the solution, that acid will be weak acid. Now, these are the points of the strength of acids, and you see one by one. First point is that acid which gives ions easily in the solution is of greater strength, and which gives ions with difficulty is of weaker strength. Second point is that acid which completely ionizes when comes in contact of water is a strong acid. Suppose any acid is in contact of water, that acid will be completely ionized. And some acids which come in contact of water, they ionize slowly, and after more amount of water, if is in contact of that acid, then that acid will be ionized further and maybe completely. So that acid which completely ionized when comes in contact of water is a strong acid. As HCl, hydrochloric acid, HNO3, nitric acid, and H2SO4, sulfuric acid. These acids when come in contact of water, they are completely ionized. Next, that acid which does not ionize completely when comes in contact of water, but as dilution increases, means as the quantity of water is increased, ionization also increases, is weak acid. All organic acids are weak acids. Acetic acid is organic acid, is a weak acid. When it comes in contact of water, a small amount of acetic acid is ionized, further quantity of water is added, then again ionized, and in this way, when at infinite dilution, acetic acid is also completely ionized. In similar way, the other organic acid, the oxalic acid, H2C2O4. Just I have told you, all acids have equal strength at large quantity of water, and that large quantity of water is assigned as infinite dilution. At infinite dilution, all acids are completely ionized, and strength of all acids are equal. Means if large quantity, excess quantity of water is present in the acid, in any acid, then that acid will be completely ionized, and that dilution, all acids are of equal strength and have completely ionized. Next point, greater the value of ionization constant, greater will be the strength of acid. Ionization constant is denoted by K. Now, suppose Ha is acid. It ionizes as hydrogen ion and A ion. Suppose there is no complete ionization of Ha. Then the ionized ion, in between ionized ion and unionized ion, there will be equilibrium will be established, and that equilibrium constant is known as ionization constant. So K is equal to hydrogen ion concentration, that is the product, and AN concentration by HA concentration. As the value of K will be greater, the strength of acid will be also greater because the product value will be greater and the reactant value is smaller, then the value of K will be increased. Next, greater the size of anion in the hydroacids, greater will be the strength of acid. Hydroacid means that acid in which hydrogen is present as HF, HCl, HBr, HF. In these acids, anions are fluoride ion, chloride ion, bromide ion, and iodide ion. Hydrogen ion is common in all acids. So these are the halogen acids or hydroacids. The size of anions as fluorine is smaller than chlorine, and the size of chlorine ion is smaller than bromine ion or bromide ion, and bromide ion size is smaller than iodide ion. We have stated that greater the size of the anion. The size of the anion is increased from left to right. The size of anion F is smaller than chloride ion. The size of chloride ion is smaller than bromide ion, and the size of bromide ion is smaller than iodide ion. So the strength of acid will be in this manner. HF will be weakest acid in comparison to HCl, and HCl will be weaker acid in comparison to HBr, and HBr will be weaker acid than HI. Means HI will be more stronger acid among all these. Next point, as smaller the fractional charges on the oxygen atom in oxy acid, greater will be the strength of the acid. Suppose hypochlorous acid HClO, see here, hypochlorous acid HCl, chlorous acid HClO2, chloric acid HClO3, and perchloric acid HClO4. Hydrogen has positive charge, and ClO as a whole will also contain -1 negative charge equal to and opposite to hydrogen charge. So in this ClO there is only one oxygen atom, and this -1 charge will be equally distributed between Cl and O. So one atom oxygen will contain -1 charge. In here there is +1 charge on hydrogen and -1 charge on ClO2 as a whole. But the single atom of oxygen will acquire -1/2 negative charge. In HClO3, one positive charge present on the hydrogen atom and one negative charge is present on ClO3 as a whole. But one oxygen atom will acquire -1/3 charges because here there are 3 atoms of oxygen. In the next HClO4 perchloric acid, there are 4 oxygen atoms, and one oxygen atom will acquire -1/4 charge. So the fractional charge on the oxygen atom among these acids is smallest in perchloric acid, and so that perchloric acid will be strongest acids among these. HClO2 more stronger than HClO, and HClO3 more stronger than HClO2, and HClO4 is more stronger than HClO3. Next point, greater the size of central atom of the acid, smaller will be the strength of the acid. Now see, here is sulfuric acid H2SO4 and selenic acid H2SiO4. The atomic number of sulfur is 16 and the atomic number of selenium is 34. Sa is the central atom in the selenic acid and sulfur is the central atom in the sulfuric acid. As atomic number increases, the size of the atom also increases. Here, the size of the selenium is more than sulfur. So, the central atom in the selenic acid, selenium, is of greater size, therefore, the strength of selenic acid will be weaker. And the size of the sulfur atom as central atom in the H2SO4 is smaller, therefore sulfuric acid will be a strong acid. Therefore, H2SO4 more stronger than H2SiO4. I am going to teach you about the basicity of acids. A strength of acid has been taught before it. The basicity of acid is counted by the number of hydrogen atom which is removed from the acid as ion. So, basicity of acids can be defined as the number of replaceable hydrogen atoms as ions in the acid is known as basicity of acids. But what is the relation between basicity of acids, molecular mass of acid and equivalent weight of acids? Is as basicity of acid is equal to molecular mass of acid by equivalent weight of acid. Suppose the equivalent weight of H2SO4 is 49 and molecular mass of H2SO4 is 98. So, from this formula, we can calculate the basicity of acid as 98 by 49 equal to 2. In similar way, we also can calculate the equivalent weight of acid as equivalent weight of acid is equal to molecular mass of the acid by basicity of acid. As you know, HCl has only one hydrogen atom as hydrogen ion replaceable. So the basicity of HCl is 1. The molecular mass of HCl is 36.5. So the equivalent weight of HCl will be 36.5 by 1 because the basicity of HCl is 1. In this way, we see the relationship between basicity of acid, molecular mass and equivalent weight of acid. On the basis of basicity, the acids are divided into 3 parts, 3 types. As first, monobasic acid. It can be defined as such acids have only one replaceable hydrogen atom as ion. Example, see here HCl. HCl when ionized gives hydrogen ion plus chloride ion, one hydrogen ion and one chloride ion. Because there is one replaceable hydrogen ion in the HCl, therefore the basicity of HCl is 1 and is known as monobasic acid. In similar way, HNO3 ionizes as hydrogen ion plus nitrate ion. There is only one hydrogen atom replaceable as hydrogen ion. Therefore, the basicity of nitric acid is 1. See, in acetic acid, CH3COOH, acetic acid. In the acetic acid, you see there are 4 hydrogen atoms, 3 hydrogen atoms here and 1 hydrogen atom here. But the hydrogen atom attached to the carbon atom are not going to ionize But the hydrogen atom attached to the oxygen atom is an allyl hydrogen ion. So the replaceable hydrogen atom in the acetic acid is only one allyl ion. So therefore the basicity of acetic acid is 1. Although the number of hydrogen atoms in the acetic acid is 4. But only one hydrogen atom is replaced as ion, therefore basicity of acetic acid is 1. Second, dibasic acids. As name implies, there are two hydrogen atoms replaceable as ions, and such acids are known as dibasic acids. Example, H2SO4, auxilic acid H2C2O4. H2SO4 ionizes as 2 hydrogen ion plus sulfate ion. Because H2SO4 gives 2 hydrogen ion, therefore the basicity of H2SO4 is 2. As definition says, the number of hydrogen atom replaceable as ions is known as the basicity of acids. H2SO4 has 2 hydrogen atoms which are replaced as 2 hydrogen ions. Therefore, basicity of H2SO4 is 2. In similar way, auxilic acid also ionizes as 2 hydrogen ions and auxiliate ion. Therefore, the basicity of auxilic acid is 2. The third one is tribasic acids. In tribasic acids, there are 3 hydrogen atoms in the acid which are replaceable as ions, and such acids are known as tribasic acid on the basis of basicity. As example, H3PO4, orthophosphoric acid. See here, H3PO4, orthophosphoric acid. In this acid, there are 3 hydrogen atoms replaceable as hydrogen ion. Therefore, orthophosphoric acid is tribasic acid. In other example is, see here, H3PO3, phosphorus acid, H3PO3. In this, 1 hydrogen atom is directly attached to the phosphorus, and rest 2 hydrogen atoms are attached to oxygen. In this case, only 2 hydrogen atoms are replaced as ions. Therefore, the basicity of phosphoric acid H3PO4 is 2. Although H3PO4 has 3 hydrogen atoms, but only 2 hydrogen atoms are replaceable as ions. Therefore, H3PO3 acid is dibasic acid, not tribasic acid. It is dibasic acid. But in H3PO4 you will see all 3 hydrogen atoms are connected with phosphorus through oxygen atom. Therefore, all 3 hydrogen atoms are replaceable as ion, and orthophosphoric acid is tribasic acid.